Welcome to Dr. Zakir Math. In this video, I'm going to solve one-dimensional heat equation, which is a parabolic equation, right? Using Bender-Schmidt method. For one-dimensional heat equation, we are going to study two methods. One is Bender-Schmidt method. Another one is Crank-Nicolson scheme. These are the two methods we are going to study. So in this video, I'm going to explain how to solve this parabolic equation, that is your one-dimensional heat equation, using Bender-Schmidt method. Let's see what is your one-dimensional heat equation. Your one-dimensional heat equation is given by Uxx is equal to A times Ut. That is dou square U by dou x square equals A into dou U by dou T. Right? Yes. Now look here, there is one more formula you have to see, which is K is equal to AH square divided by 2. So A is always the coefficient of Ut, keep in your mind. If it is not in order, please arrange it properly. According to that, you have to get the value of A. And keep one more point also, all the time the coefficient of Uxx for one-dimensional heat equation is 1. If it is not 1, make it 1 and then start the problem. For example, suppose your equation is given 2xx is equal to Ut. So, what's your A value? A value is going to become what? It is equal to 1 by 2. Keep in your mind. So, always keep your coefficient of Uxx is 1 and coefficient of Ut is your A. Right. Here, two things are needed. One is H, another one is K. Remember all of you? Two things are needed. One is what? H, another one is what? K. Right. H is for the X direction and K is for the T direction. H will be given in the question. If not, you have to choose a proper value for H. And T value, you have always T starts from 0. Starting value is what? Start from 0. Okay. But the upper limit means ending point. Ending point, you have to use this one, K value. In this way, you have to jump. But sometimes end value will be given. Sometimes end value will not be given. Keep in your mind. Now let me show you this one-dimensional heat equation is a parabolic equation, right? So to show that it is parabolic, to show that the given one-dimensional heat equation is parabolic. How to show it is parabolic? To show that one-dimensional heat equation is parabolic. Let me show. So it is parabolic. So you have to find b square minus 4ac, right? Yes. What is b square? For this you need to consider your second order partial differential equations general form. What is that? A into dou square u by dou x square plus b into dou square u by dou x dou y plus c into dou square u by dou y square, and then plus so on, it's going on. Lower order terms will go on, which is equal to 0. Right, we considered A, B, C. Why? We want B, A, C only. Right. In this case, your equation is what? Uxx is equal to what? A times Ut. So the solution will be what? U of x comma t is your solution. So it means this equation takes the model A into dou square u by dou x square plus B into dou square u by dou x dou t plus C into dou square u by dou t square. Right. So compare this equation with this your one-dimensional heat equation. What is your one-dimensional heat equation? Dou square u by dou x square is equal to what? A times dou u by dou t, right? A times dou u by dou t. So dou square u by dou x square is equal to A times dou u by dou t. So just compare this equation. What is the value of A? It is 1. And what is the value of B? It is 0, because there is no dou square u by dou x dou t. And what is the value of C? C is also 0, because there is no dou square u by dou t square. C is equal to 0. So now let us find the discriminant value, which is b square minus 4ac. So b square minus 4ac is b square is 0 minus 4 into a. I don't know because it's not available. It's available. A value is 1 and C value is what? 0. So which is equal to what? 0. In this way, if the discriminant value b square minus 4ac is 0, so the given differential equation is called as what? Parabolic. The partial differential equation is called as what? Parabolic. So now we are going to take one example, which is one-dimensional heat equation is a parabolic equation, and we are going to solve this equation. Clear everybody? Right. So keep in your mind, this parabolic nature of the equation corresponds to the way heat propagates through the domain. So it means the heat flows over the domain. Domain means overall the area fully it will develop. So it always depends on the time also, that is time dependence we say. The solution evolves over time, showing how heat diffuses. And also mathematically any change at one point is instantly felt everywhere, but physically that is idealized. So the information moves in one direction, especially forward in time. So parabolic equations requires both initial and boundary conditions to fully determine the solution. What do you mean by initial condition? At time t equal to 0. What is meant by boundary condition? At the boundary level, we did two problems on Laplace and Poisson's, right? So that is boundary conditions, right? That is why we set them carefully here. Keep in your mind. Okay. Now let's solve one equation, one question, one dimensional heat equation using Bender-Schmidt method. Solve dou square u by dou x square minus dou u by dou t equal to 0, u of 0 comma t equal to 0, u of phi comma t equal to 0. This is called what? Boundary condition. Why this is boundary condition? Because you see starting value x is equal to 0. Because the solution will be what? U of x comma t. So this is your x, this is your t, and this is your x, this is your t. So x is equal to phi. This is the boundary. Look at here. Here what is that? T equal to 0. So when t is equal to 0, it is called what? Initial condition. So boundary condition and initial condition. Very, very important. Keep in your mind. Okay. So everywhere we need to solve the one dimensional heat equation, we need boundary conditions and we need initial conditions. Keep in your mind. Boundary conditions means state at the edges of the domain. And initial condition means state of the system at t equal to 0. Keep in your mind. Clear all of you? Right. Again I'm telling again I'm telling mathematically a change at one point is felt instantly, right? Everywhere in the domain. Physically this is an idealization. But it means what? The path of the information flow only go in one direction. Always forward direction. Keep in your mind. Right. So the question is find u in the range by taking h is equal to 1 and t up to 5 seconds using Bender-Schmidt method. Right. So t is very clearly given. T is equal to what? 5 seconds. Always t must be starting value must be 0 and you are jumping into what? Up to 5 seconds. How much you are jumping? It depends on the k value. How much x value jumping? It depends on the h value. Keep in your mind. So first of all, let us take the equation. What is the equation? The equation is dou square u by dou x square minus dou u by dou t is equal to what? 0. I'm going to write this as dou square u by dou x square equals dou u by dou t. What is the general equation? The general equation is dou square u by dou x square equals a times dou u by dou t. So what is the coefficient? That is a value which is 1. Clear everybody? Right. So the first part you have to take a value from the equation. The next is condition. U of 0 comma t is 0 and u of phi comma t is equal to 0. That means at x is equal to 0, the temperature u is 0. At x is equal to 5, the temperature is equal to what? 0. Keep in your mind. So two conditions over. The third condition, u of x comma 0, that is the initial condition, which is x square into 25 minus x square. Okay, right. Now what is the next thing? Find and you are going to find u in the range by taking h is equal to 1. Look at the x value. The starting value for x is what? 0. Ending value for x is what? 5. X means you have to depend on h value. T means you have to depend on k value. Keep in your mind h value, k value. So x you have to jump according to the h. How much is given h? H is equal to 1 it is given. So I am jumping 0 plus 1 which is equal to 1 and 1 plus 1 which is equal to 2 and 2 plus 1 is equal to 3 and 3 plus 1 is 4 and 4 plus 1 is equal to what? 5. So this is your x values. T values you have to find out using the formula k is equal to a h square divided by 2. This is a value is just now we calculated from the equation. We got it from 1. We got 1. And h value it is given in the question which is 1 and then divided by 2. So k is equal to 1 by 2, right? So k is 1 by 2, which is equal to what? Which is 0.5. So you are going to jump 0.5. What is the end value of t? Which is 5 seconds it is given. So end is what? It is given 5 seconds. So you are jumping. How many times you are jumping? Adding 0.5. So always t starts from 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, and then 5. This is the ending value. Let me write in a proper way. 0.5 and then 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, and then 5. Clear, everybody? So in this way, before starting the table, just make sure your x value and your t value. Okay. So yes. Okay. Okay, right. So x value is ready, t value is ready. Okay, right. So let's start the table value. It's ready. 0, 1, 2, 3, 4, 5, and this one also k values I've written. The t values also written. Right. Now you should recollect your boundary conditions. Let me write the boundary conditions again. What is the first boundary condition? The first boundary condition is u of 0 comma t is 0. U of 5 comma t is 0. Look here. U of 0 comma t is 0 and u of 5 comma t is equal to 0. X is equal to 0, temperature is 0. X is equal to 5, temperature is 0. So where is x is equal to 0? So here is x is equal to 0, right? All these values are 0. Clear, everybody? All these values are zeros. All these values are zeros, right? Next is at x is equal to 5. Where is x is equal to 5? Here x is equal to 5. So all the values are zeros. All the values are zeros at the boundary level also, right? It is 0, right? The next is initial condition. What is your initial condition? U of x comma 0 equals x square 25 minus x square. Am I right? X square 25 minus x square. Yes. So what is the meaning of this? At t equal to 0. Where is t equal to 0? This is the line t equal to 0, right? This is the line what? T equal to 0, right? So when t is equal to 0, this one. It means what? This is x square 25 minus x square. 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 Of course, this also x square 25 minus x square. Automatically you'll get 0. Don't worry. Right. So now you're going to put x is equal to 0, x is equal to 1. When I put x is equal to 0, 0. When I put x is equal to 1, 1, 25 minus 4, which is 24. X is equal to 2, 84. X is equal to 3, 9, 25 minus 9, which is 144. X is equal to 4, again 144. X is equal to 5, 25 minus 5 square is what? 25. So it becomes what? 0. Now you have to fill up all these remaining values. Okay, u1, we call it as u1, u2, u3, u4, u5, u6, u7, u8, u9, u10, u11, u12, u12. All these values we are going to calculate using Bender-Schmidt formula. Using Bender-Schmidt formula. So you have to write this formula in the exam. Keep in your mind. What is Bender-Schmidt formula? Ui comma j plus 1 is equal to half times ui minus 1 comma j plus ui plus 1 comma j. It means if you want to go 1 point more in the y direction and you have to see the left side x direction 1 point and the left one side and then divide by 2, which is on the upper place, because what? J plus 1 is upper, which is here. So if you want to find this one, this value and this value divided by what? 2. But instead of coming from lower value, I'm going from up. So it means what? I'm taking this value and that value. Okay. So it's so easy. Keep in your mind. If I want to fill up this one, I have to take this value and I have to take this value and I have to take this value and then divide by 2. 0 plus 84 divided by 2, 42. If I want to fill up this one, this value and this value divided by 2. 24 plus 144 is 84. If I want to fill up this one, this value and this value divided by 2, which is 114, right? And if I want to fill up this one, this value and this value divided by 2, 144 divided by 2, this is 72, right? If I want to fill up this one, this value and this value divided by 2. So 0 plus 84 is what? 42. So if you want to fill up this one, this value divided by 2. So which is how much? 78. Okay. If you want to fill up this one and this one, you're going to fill up what? This divided by 2. And if you want to fill up this one, you have to this one and this one divided by 2, which is again 70 to 114 divided by, which is 57, sorry, 57, right? So is it okay? Shall I fill up all these values? Yes, okay, right. So it is this value 0 and this by 39 and this is 78, 60, 67.5. No, sorry, I took the wrong value, wrong. Okay, right. So 0, this value is wrong and this value is wrong. 1.50, 78, which is 39. Then this value 42 plus 78. So which is going to be 120, right? So which is 60, right? And then this 67.5. This is going to become 39. Next, this is 2. So this is 30. This is 53.25, 49.5, 33.75. Next, I have to go to 2.5. Let me need this value. 0, 53.25, it is 26 something. So 26.625, 39.75, 43.5, 24.75. Next, this value and then this value divide by 2. That is Bender-Schmidt formula. Okay. So which is 19.875 and 35.0625, 32.25, 21.75. So if you want to fill up this one, this value divided by 2. If you want to fill up this one, this value divided by 2. If you want to fill up this one, this value divided by 2. This value divided by 2. Okay, right. So I'll get 17.5313, 26.0625, 28.4063 and 16.125. And the next is 13.0313, 22.9688 and 21.0938. This is 22 point. Okay. And then it is 14.2032. Next is this is 11.4844. I'll reduce the size. Okay, then 17.0626, 18.586, 10.5469 or 895469. A calculator very small. Next is 8.5313, 15.0352, 13.8048, 9.293. So this is the last value. So what is the approximate solution? The approximate u of x comma t, the solution at t is equal to 5 is calculated as what? U of 1 comma 5, which is 8.5313, and u of 2 comma 5 is equal to 15.0352, and u of 3 comma 5 is equal to 13.8048, and u of 4 comma 5 is equal to 9.293. Why, teacher, you did not write u of 0 comma 5? Because it's already given in the question, which is a boundary condition, and u of 5 comma 5 is also given in the boundary condition. Okay, so no need to write. So these are your final answers. So the table values are very much clear. You know how to fill up the table. So the boundary condition you are going to fill up and the initial conditions you are going to fill up. So easy. And you're going to write x value depends on h. T value depends on k. Keep in your mind. Okay. Let's do one more question. Okay. This is question number 2. Right. Solve uxx is equal to 32 ut. Uxx is equal to what? 32 ut. So the coefficient attached with ut is your a, which is equal to 32. And h value is 0.25. X value is 0 and x value going up to 1. You can say like that. So x value starting from 0 and ending with 1, which is a range of what? 0.25. You are adding 0.25. So 0.25, 0.5 and 0.75. And t value you have to find out. So t value always starts from 0. Is there anything t is given? It is not given. 1 step, 2 step, 3 step, nothing is given. Okay, right? So it is not given. So you have to go with what? Your own choice. Let me write what is the value. K is equal to a h square divided by 2, right? So a value is how much? Which is 32, right? And h value is given 0.25 the whole square divided by 2, which is equal to k. 1 minute. Where is the calculator? It's here. Okay. So which is k is 32 bracket close, and then this one 0.25 bracket close square divided by 2. Okay, it's equal to 1. So k value I'm getting is 1. So t is not given. So it is your choice. I feel maximum you go for 3 steps at least. Okay, at least go for 3 steps, but 4 is better. You can say like that, but 3 is okay. So jumping as plus 1 based on the k value, you have to jump. So plus 1 and then jumping plus 1. So let me calculate up to what? T is equal to 3. Okay. So it's 1, 2, 3. So I will start. Okay. So x value and t value, right? X is starting from 0 and 0.25, 0.5, 0.75 and 1, right? So using the conditions. Now t value, it's up to you. Starting from 0, I'm calculating 1, 2, 3 and then 4 because my table is up to 4, and one more table I extended, but still no need. Right, now you have to fill up this by your boundary conditions. What is the question given? Your question is given u of x comma 0 is equal to 0, u of 0 comma t is equal to 0, and u of 1 comma t is equal to what? T. Okay, right. So when this is called, the temperature function is u of x comma t for the heat equation. So this is called initial condition, this is boundary condition, and this is boundary condition. Okay, BC means boundary, IC means initial condition. So this is for x, right? When x is equal to 0, temperature is 0. This is x equals 0, right? So this is x equals 0. So all will be 0, 0, 0 and 0. Right. Now for x is equal to 1, this is the value x. X is equal to 1 is the last boundary, which is given as t. So the function is what? T, t, t. So the function is t, t, right? When I put t is equal to 0, this value, I have to choose this value. Okay, yeah, the function is t. Last problem I gave x value, but now it's t value. T equals 0, 0. T is equal to 1, it's 1. T is equal to 2, 2. T is equal to 3, 3. T is equal to 4, it's 4. Okay, right. Now the next is what? These two conditions finish. Boundary condition finish. Now let's go for initial condition. Initial condition means what? T equal to 0. Where is t equal to 0? T equal to 0 is this one, the first row. This is t equal to 0. T equal to 0, the value is what? 0. So you're going to put the 0, 0, 0, right? The remaining all these values you are going to calculate using what? Bender-Schmidt method. Okay. So you need to write the formula, keep in your mind. Okay, right. So you're going to calculate this one by adding this and this by 2. Dividing by 2, this is 0. So this one and then this one dividing by 2, which is 0. This one and this one divide by 2 is 0 because it's 0. If you want to calculate this one and this one divided by 2, 0. This one and this one divided by 0, 0. This one and this one 0.5. Is it okay? Right. So now because it's 1 divided by 2. So for this one you have to add this one and this one divided by 2, which is 0. This one you have to add and this one you have to add. 0.5 divided by 2 is what? Sorry. This one, this. Okay, this one is 0, 0.5, which is 0.25. Okay. and this one and this one. 0 plus 2 by 2. This is going to become 1. Okay, right. Now if I want to fill up this one and this one. So 0.25 divided by 2. 0.25 divided by 2, which is equal to 0.125, right? 0.125, right? And this one divided by 2. 0 plus 1 divided by 2 is what? Which is 0.5, right? And this one adding dividing by 2. So this is going to become 3 plus 3.25. 3.25 divided by 2, which is equal to 1.625. So 1.625. So finally your answer is what? At u of x comma 1 everything. So when u at x is equal to 1 and t is equal to 4, and u of 2 comma 4, u of 3 comma 4, and u of 4 comma 4, I think up to 4. U of x is equal to 0, sorry, 0, not x is equal to 1. U of x is equal to 0, x is equal to 1, x is equal to 2, x is equal to 3, and x is equal to 4, and x is equal to 5. Okay, right. So the values are, do I need to write this final answer? Not necessary, but I'm understand. This is 0 already given, right? 5 comma 4 is 4, sorry, it is not 0. And this value is 0.125, and this is 0, and 0, 0.125, 0.5, and 1.625. I think I'm making mistake. 0 comma 4 is 0, and then 0.25, 0.125, it's 1, 2, 3, 4. 4 values. I think 4 values only, but not necessary. It's okay. You can fill up the table. You may confuse with this. Right? Okay. So it is clear, everybody, how to solve a one-dimensional heat equation. It is clear or not? Yes, it's very, very clear, right? Yes, totally. It is so easy. The only thing is what? You need to find out the A value, K value, H value. All these things carefully you have to find out. Filling up the table is not so difficult. It's so easy, right? Yes, alhamdulillah, we have solved the heat equation using Bender-Schmidt method with the corrected initial conditions, right? If you found this video is helpful, subscribe, like, and share. East or West, Dr. Zakir Math YouTube channel is the best place to make learning math simple and fun. Keep practicing, stay curious, and inshallah we will meet in the next video. Until then, it's bye from Zahir. This is 0352. Okay, right. That's what we got at 0352. Yes. Yes, I'm posting the videos during vacation, but I don't know whether you are studying or not. But don't waste your time. Please work very hard. See you. Take care. Until then, it's bye, 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 bye. Okay, let me check the values of this one. Parabolic equations. One dimensional. Yes, right. I will do 2 more questions also, right? Thank you. Bye-bye.